I'm doing a presentation on the fluoride pollution. And basically fluoride is a anion of chlorine, so it's written as F minus. And most dentists use it today to like prevent tooth decay. So whenever you go to the dentist's office, they put fluoride on your mouth. And it's found naturally in soil, water, and foods. And it's actually the 13th most abundant element in the Earth's crust. And well, in naturally concentrations of fluoride are 1.3 parts per million in seawater and 0.01 to 0.03 parts per million in fresh water. And the source of this pollution is that authorities add this fluoride to tap water because they believe it'll help with dental health. They actually add it at the water treatment plant before it gets sent out to the public water. And studies shown by the American Dental Association and the British Dental Association show that the places that had fluoride added to their water actually had better dental health than the ones that did not. But there are some negative effects, such if fluoride concentrations become too high, then that can lead to dental and skeletal fluorosis. Dental fluorosis is a permanent discoloration of tooth enamel. So if you ever get like you get like permanent white spots on your teeth. And you're exceptionally vulnerable during childhood. Once you get past the age of 9, you're usually safe from getting this dental fluorosis. But you can get skeletal fluorosis, which is hardened bone with less elasticity, and that makes bones easier to fracture. And to test for fluoride in your water, I found this at microwaterman.com. There's a fluoride testing kit that you can get that has this disc that you can get, which you take 10 milliliters of your water sample and put 20 drops of hydrochloric acid into that water sample, and then you poke a hole in your test disc and place it in that water sample, and after 5 minutes you take it out again, and the more spread out the red rings are, the more fluoride concentration there is in it. So if it's way out there, there's a whole lot of fluoride in it. And to remove fluoride, there's a couple different things you can do. There's a reverse osmosis, which forces water to go through a semi-permeable membrane, but that method is very expensive. That most people cannot do that. And then you got distillation, which when you boil different substances have different boiling points, so you're sometimes able to get fluoride out that way. But probably the most reasonable method to use would be activated alumina, which is aluminum oxide, and basically you put this into the water containing the fluoride, and it actually absorbs the fluoride that's in the water, and the longer you leave it in, the more fluoride it'll take out. Like, it'll definitely put it from 0.05 parts per million to 0.01 parts per million. And the lower the pH and the lower the temperature of the liquid, the better able it will work. These are references. Are there any questions?
Are the levels in the freshwater, is that like drinking water then?
Yeah, that's well, the thing is that would be considered naturally. Like, I believe I read somewhere that the ADA, the American Dental, actually says they can get 0.17. Like, because they actually add it. That's what they consider that safe. But there are some cases where it gets too much, and then some people are more susceptible than others, and they can get the dental fluorosis on their teeth.
What's the source of it? Like, besides us putting it in at the source of like city water, where are we seeing it naturally occurring? Like, how is it a natural? Natural is not the right word, but how is it a natural pollutant?
I believe it's like in rocks, and when it breaks the rocks up, it kind of gets into the water. Like, I know in seawater, it kind of can bond with sodium, because there's a lot of NaCl in there, and because like what he was talking about with the chlorine, that likes to bond, but then sometimes also the chlorine likes to bond with the sodium, and then that's one way it's in seawater.
Any other questions? All right, thanks, Tyler.